Here is a quick showcase of the game. The player has 25 seconds to get to the final gate. Going through normal gates adds 5 seconds to the timer. Notice the changes in speed to the left of the screen. This is the header file for the vehicle pawn. This inherits from the wheeled vehicle pawn class. Notice how only the functions that need to be accessed outside of the class are in public. In the constructor, the spring arm, camera and engine audio component are set up. The engine audio and update in air control functions are called on tick. These will be discussed later in the video. Input functions are bound, and then you can see how easy it is to apply the basic movement functions. Just get the vehicle movement component. I am using the vehicle variety pack on the Unreal Store for the sports car. Setting up the animation blueprint for the wheels is done here and then applied in the blueprint. The wheels are set up in the vehicle movement like this. Then I applied blueprints for the front and back tires and give them the correct bone name in the car's skeleton. I then applied a torque curve to the engine, however this needs tuning. Here is a look at the game mode header file. I have moved the necessary functions to protected. On begin play, the game shows the loading widget. After 1.5 seconds the loading widget is hidden and then the main game widget is shown. Once the game has loaded, a 25-second timer begins. If this timer gets to 0, the player loses. Once the game ends, the player's input is disabled, then a win or loss screen is shown accordingly. Here is the header file for the checkpoint gates. Made up of static meshes, a sound cue and a box collision. The constructor adds all of the components to the scene and sets their defaults. The box overlap is bound to an event on begin play. Then once the car overlaps with the box, a sound cue is played. Then if the instance of the checkpoint is the finish line, the game will end, and if it's not, the player will be given an extra 5 seconds. Here is a look at the blueprint for the checkpoint, where the meshes have been set to flags. In the level I can set the instance of the flag to check if it's the finish line or not. Here is a look at the code for the main car widget. I have left everything underprotected here. In the native construct, I bind the speed and time functions to be called every 0.1 seconds. Update time label text sets the time text to be equal to the time remaining. Update speed text gets the vehicle's forward speed and then converts it to miles per hour by multiplying by 0.0237. This will be set to a variable rather than a hard-coded value in future. The code for the win and lose screen are identical, however they both have different text. Clicking the Restart Game button just opens up the same level again. This code basically allows the player to control the car if they're in the air or upside down. A line trace is drawn to the floor, and if it's hitting the ground, then it's not in the air. A check is also done to see if the car is on its back by calculating the dot product between the car's up vector and the world's up vector. If the car is in the air or flipped, I get the forward and steering input of the car. I set values for pitch and roll air movement. And if the car is flipped, there is more roll force than if the car is just in the air. The movement vector is then calculated with these values and multiplied by delta time to make it frame rate independent. I then get the rotation from the movement vector. This is then applied to the mesh. I can flip the car here. Here is the engine audio function, updated on tick. The minute and max speed are taken from the vehicle's movement component. This function basically sets the RPM range value in the Metasounds audio component. You can see the RPM range here. There are two wave assets used here, one for the engine starting and the other for high engine revs. Thanks for listening.